Razi, can you tell me
What, ma'am?
what is the first law of planetary motion? Can you recall?
Ma'am, it was like, ma'am, it was a shape of ellipse where Earth is on one of its foci,
No, not Earth.
and ma'am, sun. Sorry, sun. Sun is one of its foci, and the Earth and all the planets are revolving around it like ellipse is an oval shape, and they are revolving around. Ma'am, it was like
Means path of
when
any planet around the sun is follows the shape
ellipse.
of an ellipse. Okay, and
Yes,
with the
ma'am.
sun at one of its foci.
Yes, ma'am.
The sun
And
at
when
one of the foci. And what about perihelion and aphelion?
Ma'am, when the Earth is farthest from the sun, it is and its speed is the slowest is known as aphelion, and when the Earth is closest to sun and its speed is faster is known as aphelion.
Known as perihelion.
Oh yes, ma'am, perihelion.
Second law. Second law. Hello.
Yes, ma'am.
Yes, ma'am, I already heard you. I thought my voice got broken. Oh, okay, Razi, second law. Can you recall? If you can recall, then say. If you can't, then I will tell.
No, ma'am, I cannot recall the whole part.
I'm showing you this
Yes,
diagram.
ma'am. Yes, ma'am. That diagram I can recall that area of aphelion is equals to area of
No, 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 no,
perihelion.
no, 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 no. It's
Ma'am,
not the same.
can I try to
Yes,
tell?
yes, right.
Is it like for the area
Hmm.
that takes up for 1 month to take around the sun, the given period of time, how much
Hmm.
how, like from wherever the in an ellipse. So from the sun
Hmm.
to like from one, it traveled from C to D. So from that 1 month,
Hmm.
so, and then you do it to the sun, and that area will be equal to, even if you take from A to B, which is
Hmm.
also 1 month, and
Hmm.
take it and make a thing out of it, like
Hmm.
a triangle
Join.
shape. They're joining it, and the area of both of them will be the same. So, like, no matter
Yes.
how much time it took, the time will
Hmm.
always, what do you say, like the
Means the line joining the planet and the sun with equal areas and equal intervals of time, right?
this
This
one for
is
equal hours of
these are
time,
the 12.
area will always be the same.
These are the areas swept by the planet. Okay, the area swept by the planet in 12 months. Okay, so in the first month it will be A1, means it has moved from A point to it's moved from A point to B point. Okay, A point to B point. So when the planet has moved from A point to B point and line joining the area swept by the planet, line joining the area swept by the planet with the sun, means this line joining this will all will be all the areas will be equal if we take equal intervals of time, right? This is of 1 month. And again, if the from a again the area swept by the portion that has been swept by the planet again from B to C, then again line joining the area, it will be what? A1 will be equal to A2. Okay. Likewise, it will be means as it's going as it will be going far away from the sun, the this portion will get less, right? This portion will get less, right? This portion. But this portion will get elongated as it gets far from the sun. This portion will get elongated, and due to which the area will be equal to the portion that has been swept by the
Perihelion side.
hair in the perihelion place, right? In the perihelion place, because this portion will be more, but this portion will be less. This portion will be less, right? This portion will be less. So it will be what? Equal to these. All of the portion will be equal. Okay. So this is the second law. And third law is if we take the mean distance of the planet from the sun, right? Mean distance of the planet means all of the distance and taking the mean of that, all of the distance from distance of the planet from the sun. So if we take mean distance and we take the cube of that distance, that mean distance, it will be directly proportional to the square of the orbital period t. Means whatever time it takes to complete one revolution. Okay, it will be equal to that, the square of that time period. Okay, so can write it like r cube proportional to t square. R is the mean distance of the planet from the sun, and it will be directly proportional to the square of the orbital time period. Okay, so which we can write it like k is equal to r cube by t square. Okay, k is equal to r cube by t square. Fine. This is the way the k is called the Kepler's constant. K is called Kepler's constant. Now he couldn't explain what he couldn't explain. What he couldn't explain in his planetary motion. Kepler's what couldn't he explain? Aram, can you tell me? These three he told us, but he couldn't explain one thing. What was that?
I don't know. I wasn't there in the class.
Okay. Grazi?
Ma'am, like the radius cubed is proportional to the time squared.
No, he told us this. He told us this.
Oh yeah, that's the third law.
He couldn't explain that how the planet.
Motion of the planets.
Yes, he couldn't explain the motion of the planets around the sun. That what is that cause that brings
Gravity.
that brings the planet to revolve around the sun. That helps the planet in revolving around the sun. He couldn't explain this. Okay, and that was explained by Newton. Yes, and one thing Newton used, he used Kepler's third law. This relation. He used Kepler's third law in calculating the gravitational force of attraction. He used Kepler's third law. Who used? Newton used. Okay, now we'll see how he used his third law. Okay, this is what F is equal to mv square by r. Do you know about this? What is this? F is equal to mv square upon r. What is this? This is the force that is acting on the planet when it's revolved around the sun. Okay, fine. So this is the force that is that is getting act in the on the planet. Okay, mv square by r, centripetal force, which is called centripetal force. Okay, this is called what? Centripetal force. F is equal to mv square by r. And one more Tiranga quiz. We have Tiranga quiz also. We'll do it after this. Tiranga quiz.
What?
So,
What is it? What?
Tiranga quiz.
What is Tiranga?
Tiranga is Tiranga. I have named the quiz that Tiranga quiz. Okay, mv square by small r. Yeah, mv square by small. This is the first relation. Okay, this is the first formula that we have to use it here. So F is equal to mv square by r. And we know, we are already knowing that T is equal to what? 2 pi r by v. Yes or no? Distance upon velocity, right? And distance in the circular motion is what? 2 pi r, right? The circumference. Razi, you are getting, no?
Yes, ma'am.
So 2 pi r upon v. Okay, T is equal to 2 pi r upon v, orbital time. Fine. So we have to figure out for v here. 2 pi r by t. Can we write it like this? V is equal to 2 pi r by t. Can we write it like this?
Yes, ma'am.
Now, substituting this value of v in this first equation. Let this be first equation. Okay. Let's substitute the value of v in first. Substitute the value of v in equation first. So what it will be? F is equal to mv square by r. So m by r will be as it is. Arhan, are you saying to what I'm writing? And v square, what we can write it to v square 2 pi r by t whole square. Can we write it?
Yes, ma'am.
Can we write it? Yeah, no? Now, what we can do here? Now, simplifying this, f is equal to m by r. Dikh raha hai na?
Yes, ma'am.
And 2 pi square r square by t square. Right?
Yes, ma'am.
Okay. Now, one R will get cancelled by this R, right? One R will get cancelled. Sorry, this will not be 2, this will be 4 because 2 twos are 4. No one is telling it to me. Okay, so what else? 4 pi square m and 1 R also is there upon t square. This is force which we have got. Okay. Now we are knowing this, that from the Kepler's third law of motion. What is that? From Kepler's third law of motion. What is that? R cube is equal to kt square. This is what we have learned here. No? R cube is equal to kt square. This is what written here. Right, Razi? K is equal to R cube by T square. So R cube will be
Yes,
equal
ma'am.
to KT square. KT square. Now, can we write in place of T square? Let this be second equation. Can we write this? Means this can be written as T square is equal to R cube by K. Right? R cube by K. Now, in place of this T square, we'll write F is equal to 4 pi square mr. In place of T square, we'll write what? R cube by K. R cube by K. By K means will go to here. Okay, it will come to the numerator. And one R will get cancelled by this R cube to make it R square. So what we have got here, F is equal to 4 pi square mk by R square. Okay. Now we have got to know about this, that force is inversely proportional to r square, distance square of the distance between the planet and the sun. This is what we got this relation. 2 pi square km. 2 pi square mk or km, whatever you write, by r square, which we have got it like F will be proportional to 1 by r square. And also we know that now the force is inversely proportional to the square of the distance between the planet and the sun, right? Between the two bodies. In the gravitational, in the first topic, we already have discussed this, right? The gravitational force between the sun and the planet is inversely proportional to the square of the distance between their centers. Okay, he used this way. We say that Newton used Kepler's third law of planetary motion in determining the relation between force and distance. Distance between the sun and the planet. Okay. Now free fall. What is free fall? Free fall is when we drop anything and when we drop anything and that object fall into towards the earth under the force of gravity, and no other force will be acting on. Okay, free fall is that. Means dropping anything, not throwing anything, dropping anything. Fine.
Yeah, like this one.
With no other external force.
Yes, ma'am, but there is air drag.
Yeah. When objects fall towards the earth under the influence of earth's gravitational force alone, then these are called freely falling objects, and such a motion is called free fall. Okay. Acceleration due to gravity G. Now we'll determine the value for the relation for G and G. Okay. Now F is equal to, let's see here first. F is equal to gmm by r square, the first relation ever that we studied in the first topic, right? F is equal to gmm by r square. Now from second relation, what we are knowing, F is equal to ma. And since the object is falling under the gravitational acceleration due to gravity, so what we'll write in place of A, we'll write G. Means F is equal to mg. We'll write this J. Okay. Now, in case of this F, we'll write this mg. mg is equal to gmm by r square. This m will get cancelled. Okay. And what we'll be left with? We'll be left with G is equal to gm by r square. This is the acceleration due to gravity in any place. Means in any of the planet in the whole universe, any planet of any galaxy, the whole universe. Okay, so this will be the G. If we got to know about universal law, if we place the value of G, we place the value of m means mass of that planet, and then r square means the square of the distance, square of the radius of that planet. Okay, fine.
Yes,
Yes,
ma'am.
ma'am.
तो कैसे मिला हम लोग को ये रिलेशन? सिंपल. First we wrote f is equal to gmm by r square, gmm by r square. Okay, and due to the second law of motion, we are already knowing that f is equal to mg. Okay, f is equal to mg. Now just use this first, and using first and second relation, we'll just write the value of f in first equation, gmm by r square, where m and m will get cancelled, and we'll be left with g is equal to gm by r square. We can determine the value of acceleration due to gravity of any of the planet by placing their respective values. Okay, now we'll see the value of g for the earth. Mass of the earth is given, r of the radius of the earth is given, and g is your the value of g you are already knowing, 6.67 into 10 power minus 11. Now we'll just put the values, 6.67 into 10 power minus 11, m 6 into 10 power 24, and then a radius, the square of the radius, 6.4 into 10 power 6, the whole square. So we'll get the after simplifying this, we'll get what? 9.8 meter per second square, which is the value of g on earth, right? And if we take the value, if we place the value of g, g, this capital G will be same because it's a universal gravitational constant, so it will be same. And mass of the if we want to determine the value of g for moon, then we have to write the mass of moon here, and we have to write the radius of moon here. Okay, and then if we do the calculate, if we calculate it, then we'll got to know about the g of that moon. Okay, now what equation we'll use, what equation of motion we'll use during the free fall? Okay, during the free fall, what equation we'll use? Now see, in place of a, we have to use just g. Okay, here v is equal to u plus at is there.
Yes, ma'am.
You have to
Man,
use,
for distance we have to use h.
and for distance we have to use h. Yes, so we have to use v is equal to u plus gt. Okay, for distance we have to use h. Then we have to write h is equal to ut plus half gt square. Okay, if motion is downward, then we use plus gt square, and if the motion is upward, then it will be minus gt square. Why? Because it will be, the body will decelerate if it goes towards, if we goes upward. Okay, ऊपर जाएगी तो वेलोसिटी कम होती जाती है ना, क्योंकि ग्रेविटी तो नीचे की तरफ खींच रही है, राइट? Force of gravity is in the downward direction. So when it will be positive if the motion is downward, and if the motion is if the motion is what? Upward.
Upwards.
You have thrown the ball towards the upward, means upward, then what relation you use here? It will be minus gt square. Okay, because g will be in negative, we'll use g in negative, g will be minus 9.8. Okay, v square is equal to u square plus 2gh. v square is equal to u square plus 2gh, means in place of a, we'll write g, and in place of s, we'll write h. And also, if the motion will be upward, then it will be minus 2gh. Okay, fine.
Okay, ma'am.
In solving numerical problem, we should remember the following points. If an object falls vertically downward, this is what I have been saying, then acceleration due to gravity is taken as positive. And if it is thrown vertically upward, then the acceleration due to gravity is taken as negative. Okay, we'll solve some of the questions. First, we'll go for Tiranga quiz. What is that Tiranga quiz? Just tell me the answers. Knowing how a planet, this Tiranga quiz is based on Kepler's law of planetary motion. Knowing how long a planet takes to orbit the sun helps scientists determine the distance that plane is from the sun. Is this Kepler's first law, second law, third law? Tell me. This is about time and distance of the sun from the distance of the planet from the sun. So Is this Kepler's first, second, or third law?
Mom, it could be Kepler's third law.
And Razi, you? Razi,
Mom,
you?
third law. Mom, third law. I think third law.
Third law. Okay, fine. Third law. Now, the orbital path of a satellite has two focal points. When both focal points are together, the satellite path is an ellipse. The satellite path is a circle. The satellite path is a straight line. None of these.
I think circle.
Mom, I think ellipse.
You think ellipse?
I think circle. B part.
Mom, Amelia also thinks ellipse.
You are selecting this ellipse, Arham,
Yes, ma'am. Also Amelia.
and Razi is selecting this B, right?
Yes, ma'am. And also Amelia is also selecting.
What?
Yes, ma'am. She's new.
What you are saying, Arham?
And there's a new student.
Oh, there's a new student. Only I can see you.
And she also thinks ellipse.
What?
And she also thinks
Okay.
ellipse.
So does she understand? Has she understood everything that I taught today? What's her name?
Amelia.
Can she sit beside you?
She is sitting beside me.
Means in your right hand side. Then I can.
Yeah.
Yeah. What's her name?
Amelia.
Amulya.
Yeah.
Okay. So is this your first class?
Yeah.
Okay. Did you understand everything that I told today?
Yeah.
Okay. So and what do you think? The orbital path of a satellite has two focal points, right? When both of the focal points are together, then the satellite path is an ellipse.
Oh, wait.
The satellite
I
path
think
is
it's a circle. It has to be circle.
the satellite path is a straight line. What do you think? It'll be
Yeah.
circle. Now circle. You have
Yeah.
changed.
And because both of the points are together.
And what do you think, Amulya? Yes, Amulya, what do you think? Tell me first.
Circle.
Circle? Do you think circle?
Yeah. Yeah. Or not.
Okay, so all of you are right. Just Amulya, in the first question, what was your answer?
Third law.
Third law. Okay. So you all got ticks, and then in the third also you got ticks. So this is the satellite path is a circle because both of the focal points got merged together. Right? Got merged together to make it a circle because in circle there is one center. Okay, and when it gets stretched, then it becomes ellipse, right? Ellipse, and it gets two focal points. Now, consider a moon that orbits one of our most distant planet in an elliptical path. The distance that the moon covers each day is greatest when closest to the planet, greatest when farthest from the planet, the same everywhere, data insufficient.
Mom, A. Greatest when closest to the planet.
Ma'am, I
And-
think it should be the same everywhere, right?
Just read the
Distance, okay, the distance the moon covers it. Ma'am, it should be A.
and Amulya, A.
Yeah.
Okay, so all of you are correct in all of these. So you all have got 3 ticks. So it will be A because consider a moon that orbits one of the most distant planet in an elliptical path. The distance that the moon covers each day is greatest when closest to the planet. It will be when it will be closest to the planet because the path is just like this. Path is just like this, right?
Mom, it will follow the perihelion portion.
Path is just like this. We will get to foci. Okay, we'll get to foci. And suppose this is a moon that is revolving around the planet, around a planet. Okay, and planet is situated right somewhere here in this foci, in this focus. Okay, this is a planet and this is a moon. So the way that a planet or the planet revolves around the sun or the moon revolves around the planet is just like this. It will be what? It will be in high speed when it will be closest to the sun, when it will be closest to the planet. Suppose we are talking about moon here, so I have to say a planet. So when it will be close to the planet, it will be like this. So the motion of the moon will be like this. Can you see that?
Yes, ma'am.
Can you see that how I am moving my pen?
Yes, ma'am.
are moving, just like
Right.
this.
Yeah.
If
It's moving
it's
and then it's
Ma'am, the
moving with
fastest when you
moisture.
come to the perihelion side and the slowest when you go to the aphelion
yeah,
side.
yeah. So this is why it will be option first. Okay. So is this enough for today? Have you got everything, Amulya?
Yes, ma'am. Yes, ma'am.
Sure.
Yes, ma'am.
Then in the next class we'll be doing some of the examples. Okay, we'll be doing some of the examples on this topic, on free fall. Even you can also try questions because they are the same as that of the question in the first chapter, that is MIL, motion in what was that chapter? What is the first chapter? Motion, right? Motion.
Yes, ma'am.
So, in the equation of motion, like you face some of the problems,
You
you
got the
got.
question of motion.
Right? So these problems, these examples are same as that of that. Means in that case we are using A and H. In this case we will use G, and the value for G, if it will not be given, then we'll use 9.8, 9.8, and if it will be given in the question that we use the value of G as 10, then we will take 10 there. Okay. So should we close the class? I will also share this page, and you will try these questions. Okay.
Okay, ma'am.
Okay, ma'am.
Okay, then bye for today.
Bye, ma'am. Thank you, ma'am.
Bye, ma'am. Thank you, ma'am.